So today, I want to talk about section 11.9, the representation of functions as power series. This is our line. How to represent certain types of functions as sums of power series. We have this kind of method by geometric series. Second one, by differentiating a series. Third one, by integrating a series, by using Taylor series or Maclaurin series. The section 11.10, you can watch Kasha's video. You can find all things about the Taylor series and the Maclaurin series. Why do we express a known function as a sum of infinitely many terms? The first one, for integrating functions that don't have elementary antiderivative. The example is integral 1 over 1 plus x to the 7 dx. So we cannot find exact integral. In this case, we can use the power series representation. For approximating functions by a series, exactly section 11.10, 11.11, you can watch the Kasha's video. You can find this kind of information. The example is approximate E. So we can use Taylor series or Maclaurin series you can find. The last one, for solving differential equation, this is a method 251. It's like a little bit higher level courses. So next, geometric series. The next one, 1 over 1 minus x is like this. So the y, here. The series is given. This is power series. So here, do you remember like a geometric series? It's like a geometric series. The 1 times x. 1 times x is x. X times x is x squared. X squared times x is x cubed, and so on. What's a common ratio? Common ratio R is like x. So take absolute value. So when do you have a conversion result from the geometric series? The absolute value of a common ratio is less than 1. We have a conversion number. The conversion number is the initial, like the first term over 1 minus common ratio R. In this case, was it like a first term? The first term is 1. 1 minus the R is like X. So we have this result. The geometric series is given, we can find conversion number, just absolute value of common ratio is less than 1. So was it like idea in the section 11.9? We are going backward. Here, function is given, you can change it to the like power series representation. Exactly. Summation from n equal to 0 to infinity, x to the n. This is like idea. So how can you solve this problem? Express 1 over 4 plus x squared as the sum of a power series and find the interval of convergence. So I want to use this result. How can you use here? 1 over 4 plus x squared is given. First one, you can change it. This is 4 to like 1. How can you change 1? Only factor out 4. The factor of 4, 1 plus x square of 4. This one. The next is only split. The next one. The next is, what's the sign of middle one? Sign of middle one is like a negative sign. You need to change it. This is 1 over 1 minus negative x squared over 4. You can change it like this. So So would you like a lot of minus x squared over 4? This is exactly same to log of x. The log of x. Only plug the minus x squared over 4 into x here. Into x, you plug into here. So what happens? So we have this one. This is same to summation n equal 0 to infinity. You plug minus x squared over 4 into here. To the power n, and simplify. Distribute n to the minus 1. This is same to summation n equal 0 to infinity. Negative 1 to power n. X to the power 2 to the power n over 4 to the power n. So we have summation from n equal 0 to infinity minus 1 to power n times x to the power 2n over 4 to the n. That's it. This is the answer. So we have power series representation. So let me see. How can you find interval of convergence? We can use this one. What does it mean? You can plug the common ratio. This is a common ratio R into here. So we have absolute value of minus x squared over 4 is less than 1. You solve. So what's that? So eliminate negative sign, just absolute value of x squared over 4 is less than 1. You can multiply the both sides by 4. 4 is cancelled, crossed out. So we have absolute value of x squared is less than 4. Next, take square root. So this is same to absolute value of x is less than 2. You have to eliminate absolute value sign. X is between negative 2 and 2. So what is interval of convergence? Interval of convergence is this one. Open interval, negative 2, 2. This is interval of convergence. This is sum of power series is here. Okay, the next one. Next one. This is idea, the same to the my things. Oh, one more. Sorry about that. Here, I missed one thing. Sorry. Here, could you find my mistake? My mistake is here. You have to keep 1 over 4. Sorry, keep 1 over 4. Keep 1 over 4. Keep 1 over 4. Next, the 4 is going to inside. Same to summation n equaled 0 to infinity. Minus 1 to power n. X to the 2n over 4 to the n plus 1. So like this. This is your final answer. So right, really be careful. Always keep the coefficient 1 over 4. So like this. Okay, the next one. Here we have it, the same things. The differentiation of power series. How can you find the derivative of summation n equal to 0 to infinity c sub 2n x minus a to the power n? You can use like expanded form. Plug 0 into n, c0, x minus a to the power 0 is 1. First with the c0. You plug 1 into n, the c1 times x minus a. You plug 2 into n, c2 times x minus a square plus c3 x minus a cube and so on. The next one here. What is c0 prime? Could you run your answer? What is c0 prime? So what is C0 prime? Could you write your answer on the chatting board, please? So what's that? What is C0 prime? What is C0 prime? The first one. Do you know C0 prime? Right? The zero? The because C0 is constant. Yep. The constant prime is zero. You're right. Only zero plus the C1 minus X minus A prime here. C1 X minus A prime. So what's that? So could you write your answer on the chatting board? What is C1 X minus A prime? You know what is C1 X minus A prime? You can keep C1 just to find X minus A prime. Keep C1, X prime is 1, so A prime is 1, right? C1 times 1. C1 times 1 is just C1. So we have C1 plus, was it like a C2X minus A square prime? The C2, so X minus A square prime. You can keep C2. The 2 is down, use power rule. The 2 times X minus A times X minus A prime. X minus A prime is just 1. So we have interchange C and 2, C2 and 2. The 2 times C2 X minus A. You can do the same thing. Plug the 3 is like down. The 3 times C3 X minus A square times inner function X minus A prime is just 1 and keep going. So like this, right? This is exactly like this one. The next, you can change it back to this form. The C1 has exactly X minus A to the power 0 form, is right? This C1 is exactly same to this one because X minus A to the power 0 is 1. This is the reason. You can change it to the summation form. Summation, the starting index is 1 and equals 1 to infinity C sub 2n. Was it like a 0? The 0 is 1 less than 1. This 1 is 1 less than 2. Always 1 less than index. So we have, so one more. Here, 1 times C, 1, 2 times C2, 3 times C3. So exactly n is here. So n times C3. X minus A to the power n minus 1. That's it. Just exactly the derivative things. So we have it. So really pay careful. Was it like starting index? 0. You can take a derivative. What happens? The zeroth term. Like C0 prime equal to 0. What does it mean? The zeroth term is gone. So index changes. Just use power rule. The X minus A to the power n prime is n is down. And X minus A to the power n minus 1. N times X minus A to the power n minus 1. This is exactly derivative. So summarize. Summation from n equal to 0 to infinity, Cn, X minus A to the power n prime. So we have the derivative is going to inside it, take a derivative, really be careful, index change it, right? Here, n times Cn, X minus A to the power n minus 1. This is like a whole idea. Integration of power series. How can you do that? The power series is given, you can take the integral. Here, just to use substitution rule. The u is inner function x minus a, the du is x minus a prime dx, only dx. So like this one, we can change it. So we can replace x minus a by u. Here, dx by du. du, change. Next, you have to expand. The summation from n equal to 0 to infinity, the Cn un is C0 plus C1 u plus C2 u square plus C3 u cube and so on. This is the same to integral C0, exactly C0 u1 plus the here integral C2u, you keep C2 u square over 2 plus C3, sorry, C1, about that, C1, sorry about that, here, the C2, you keep C2, the integral u square is power rule, u cube over 3, plus C3, u to the 4 over 4, and so on. So this is like indefinite integral, we need constant C, like this, right? The next, you can change this one to the summation form. Summation n equal 0 to infinity. This one is C sub 2n. What's that? This is u of 1, power 1. So this index 1 is, sorry, this power 1 is always greater than 0. Power 2 is the 1 more than 1. So this 2 is 1 more than 1, exactly u to the power n plus 1 over n plus 1. So we have this kind of things. So like this, you can change back. Was it like u? U is x minus a. You can change back into here. We have this form. So what's that? In this case, only take out summation. So find integral. So you can add C because this is indefinite integral. So only use power rule over x minus a to the power n. We have x minus a to the power n plus 1 over n plus 1. You can use power rule. This is whole idea for solving this problem. So when you summarize the differentiation and integration of a power series, if the power series summation Cn x minus a to the power n has a radius of convergence r, then the function f defined by f of x equals C0 plus C1 times x minus a plus C2 x minus a square and so on. Exactly summation from n equal to 0 to infinity Cn times x minus a to the power n is differentiable and therefore continuous on the interval. F prime of x is, we have this one from the previous result. So integral f of x dx is the C plus summation n equal to 0 to infinity Cn x minus a to the power n plus 1 over n plus 1. Was like a radii of convergence of power series 1 and 2. So original one has radius is r, radius convergence r. So was like f prime doesn't change. The integral doesn't change. Always same. Both are like this. That doesn't change. It's like a whole idea. So we think about this one. So how can you solve this problem? So do you have any idea for solving this problem? So do you have any idea? How can you find this one? So we can use this geometric series. 1 over 1 minus x is summation from n equal to 0 to infinity x to the power n. So we have it. So the next, you can take derivative the both sides. We have power is like this way. What's that? You can use 1 minus x equals summation n equals 0 to infinity x to the power n, you can take a derivative of both sides. Take a derivative of both sides. What is 1 over 1 minus x? Do you know that? What is 1 over 1 minus x prime? You can use quotient rule. top one prime times bottom one minus top one times bottom one prime over bottom one squared. So what's that? top one 1 prime is just 0. The 1 minus x prime is negative 1. The negative 1 times negative 1 is positive 1 over 1 minus x squared. So we have it. So left-hand side is 1 over 1 minus x squared. So how can you find this one? So let me see. You can keep summation. The x to the n prime. What is x to the n prime? Could you run your answer on the chatting board? What is x to the n prime? So what is x to the power n prime? So do you know the answer? So what is x to the n prime? Do you know that? Yeah, you can use power rule. This one, yeah, right. What is initial index? What's that? N equals, what's that? Do you know this one? What is one? Yes, change one. Do you remember previous one? The power series has n equal 0 to infinity given. Take a derivative, change one. So like this. So n equals 1 to infinity. So like this. So that's it. We have it. We have this result. Exactly the first problem. The next, find radius of convergence. How can you find the radius of convergence? You can going back to example. Original series has radius r. What is derivative? The radius of derivative is doesn't change, same r. So here, what's that? Doesn't change. Here, this one is original one has r. What is derivative one? Radius convergence doesn't change, 1, like this. Doesn't change, 1. The next, how can you find power series of this one? Here, the x cubed over 1 minus x squared. So what's that? So you can use previous result, right? This result, how can you do that? So how can you find this kind of things? You can use previous result, 1 over 1 minus x squared equals summation n equals 1 to infinity n times x to the power n minus 1. Only multiply the both sides by here, x cubed. So what's that? This side has x cubed over 1 minus x squared equals here. X cubed is going to inside. Summation, the n equals 1 to infinity n times x to the n minus 1 plus 3. Only add exponent, n minus 1 plus 3. So we have summation n equal to 1 to infinity n times x to the n plus 2. What's the radius convergence? Here. So we can use This one, only multiply by x cube, radius convergence doesn't change. 1. It's like a whole idea for solving for this kind of problems. It's good. This is idea. So one more example. I'm going to give another example here. How can you find 1 over 2 plus x square square? How can you use power series representation? So this one is similar to this rule. So we have it. We can use the previous result. What does it mean? Only change it 2 to 1. Change it 2 to 1. How can you do that? Only take out 2. 1 plus x square over 2 squared. So like this is right. The 2 plus x squared is same to 2 times 1 plus x squared over 2. The next distribute power 2 to the 2. The 2 squared is 4. Only 1 plus x squared over 2 squared. Next 1 over 4 times. You can change it middle sign negative, the negative x form here, 1 minus negative x squared over 2 squared. So you can use summation form here. Summation form n equal to 1 to infinity, same. So what happens here? Only plug common ratio part minus x squared over 2 into here. So this one. So we have you keep 1 over 4. You have to keep the 1 over 4 times. This one is only the take out 1 over 4. Only take out 1 over 4. The 1 over 4 is outside. It doesn't matter. So here, minus x squared over 2 into x. You have to keep n times the negative x squared over 2 to the power n minus 1. So like this. So we have 1 over 4 summation n equal 1 to infinity n times distribute power n minus 1 to minus 1, the negative 1 to power n minus 1 times x squared to the power n minus 1, x squared to the power n minus 1 over the 2 to the power n minus 1. The next here, was it like a 1 over 4? The 4 is exactly same to 2 square. 2 square. You can keep summation n equal 1 to infinity. You have to keep this one, the minus 1 to power n minus 1 times n times. So we can distribute 2 to the n minus 1, x to the 2n minus 2 over the 2 to the power n is going to inside it. 2 to the n minus 1 plus 2 is, you can add the exponents, n minus 1 plus 2, 2 to the n plus 1. So that's it. This is exactly power series representation by using this, right? It's like a whole idea for solving this kind of problems. The main idea is the take derivative. Here, find a power series representation for ln of 1 plus x and each radius of convergence. So how can you find these kind of things? We can use same rule, the geometric series 1 over 1 minus x is summation from n equal to 0 to infinity, x to the n equals 1 plus x squared plus x cubed plus something like that. So how can you find the power series representation for ln of 1 plus x? How can you find? So first one, you can take derivative of this one. This one, take derivative. So what's that? So could you write your answer on the chatting board? What is ln of 1 plus x prime? So could you write 1 over 1 plus x? Is it right? 1 over 1 plus x. So how about the other students? You have the same answer. Could you write your answer? So what's that? Yeah, answer is, you're right. The 1 plus x prime over 1 plus x. So exactly 1 over 1 plus x. You're right. It's good. The next tip. I'm going to change this one to the power series by using this result. You can change the positive sign to the negative sign. How can you do that? 1 over 1 minus negative x. Change it like this. Next, only substitute x by minus x. You can plug into here, and you plug into here. So what happens? So we have this one. Summation, the n equal 0 to infinity. We have negative x to the power n. So you can distribute power n to the minus 1 and x, the same to summation n equal to 0 to infinity, minus 1 to power n, x to the power n. So what kind of result do we have? We have this result. The derivative 1, the ln 1 plus x prime. Same to what? Here. Summation n equaled 0 to infinity, minus 1 to power n, x to the power n. So like this. So one more. How can you find radius of convergence of this one? Only plug common ratio negative x into here. So plug into here. Exactly. Absolute value of negative x is less than 1. So minus 1 is gone. Absolute value of x is 1. So radius convergence is 1. So like this. The next tip. What's the main problem? Main problem is ln of 1 plus x. Here, we have this equation. How can you eliminate the derivative? How can you eliminate derivative? Could you write your answer on the chatting board? How can you eliminate this integral? Sorry, how can you eliminate this derivative? So do you have any idea? How can you eliminate? How can you eliminate this derivative? So do you have any idea for eliminate derivative? So how can you eliminate this derivative? The idea is take integral the both sides. Take integral the both sides. So like this. So what's that? Here, integral derivative is gone. Just ln of 1 plus x is here. Equals this one. You can take out summation, take out constant. Only summation n equal 0 to infinity. Take out coefficient minus 1 to n. Just integral x to the n dx. So what's that? So we have ln of 1 plus x equals summation n equal to 0 to infinity minus 1 to n. The integral x to the power n is power rule, x to the n plus 1 over n plus 1. So like this. So one more. This is indefinite integral, just write c. And the interchange is cn summation, c plus summation from n equal to 0 to infinity minus 1 to power n, x to the power n plus 1 over n plus 1. So we have this answer. So what does it mean? The ln of 1 plus x is this one. So next, this is not a final. You need to find c. How can you find c? The c is like an arbitrary number right now, but ln of 1 plus x doesn't have an arbitrary number. How can you find c from this equation? How can you find c from this equation? Equation is ln of 1 plus x here. ln of 1 plus x is c plus summation n equal to 0 to infinity minus 1 to power n x to the power n plus 1 over n plus 1. Oh yeah, you're right. You plug the one number into x and find c. What is like a possible x values? We have any number between minus 1 and 1. This is like a radius of domain, a radius of convergence. You can choose any number between minus 1 and 1. The 0 is easiest one, is right? You can choose x equal to 0. So you only put x equal to 0 into x. 0 into x, what's that? ln of 1 plus 0 equals c plus summation n equal 0 to infinity minus 1 to power n times 0 to the power n plus 1 over n plus 1. So what happens? This one, here. 0 to the power n plus 1 is 0. 0 of n plus 1 is 0. 0 times minus 1 to the n is 0. Summation also 0 is gone. So we have only this one. ln of 1 equal to c. Do you know what is ln of 1? Could you write your answer on the chatting board? What is ln of 1? ln of 1 is, could you write the answer from the other students? How about the other students? Is it right? Okay, thank you. So c is what? Yes, ln of 1 equals 0. So next, you plug c equal to 0 into here. So we have final answer. What's your final answer? The final answer is here. So ln of 1 plus x. This one is c is what? 0. You plug 0 into here, c is 0. Just summation n equal 0 to infinity minus 1 to power n x to the n plus 1 over n plus 1. What is radius of convergence? The original one has radius convergence is 1. The take integral, the radius convergence doesn't change, just 1. So like this. This is whole idea for solving this problem. The procedure is like this. So we have it. The next tip. I want to change this one a little bit. Here. Only plug 0 into here. Minus 1 to power 0 is just 1. The plug 0 into here, x. We have x over 1. Next, plug 1, negative x square of 2 plus x cube over 3 minus x to the 4 over 4 and so on. I can change it to the summation form. The initial index is just 1 to infinity. How can you do that? You can change n equal to 1. The first term is positive. Second term is negative. Exactly. Minus 1 to power n minus 1. The another one is x to the power n over n. So we have it. This one, radius r equals 1. You can use this notation more. That's right. So you need to memorize. This rule is better. What's that? Here. You can memorize this one. Ln of 1 plus x equals summation n equals 1 to infinity minus 1 to power n minus 1 times x to the power n over n. The radius convergence is 1. This is like this. You got it? So one more. I'm going to give one more example. How can you find ln of the 2 minus x squared? How can you find power series representation of ln of 2 minus x squared? How can you find? So, do you have any idea? How can you find ln of 2 minus x squared? Do you know that? So take out 2, yeah, so what does it mean? So if you want to find ln of 2 minus x squared, so don't use this kind of things. Ln of 2 minus x squared prime, find the algebraic form. You can use a geometric series, find power series, take integral. No, don't do that. This is like sometimes waste your time. What's the best way? You can use, yes, previous result. Only change it. 2 to 1, ln, take out 2. 1 minus x square of 2. Same to ln of 2 plus ln of 1 minus x square of 2. So this is like a negative sign. You can change it positive sign. How can you do that? ln of 2 plus ln of 1 plus negative x square of 2. The change. The next only plug minus x square of 2 into here. Into here. So what does it mean? It's the same to keep ln of 2 plus this one is summation n equal to 1 to infinity, n equal to 1 to infinity minus 1 to power n minus 1 times negative x squared over 2 to the power n over n. So like this. This is the same to ln of 2 plus summation n equal to 1 to infinity minus 1 to power n minus 1. So let me see. What is this part? I'm going to simplify here. We can distribute n2 minus 1. We have negative 1 to power n. The power n is going to x squared, x to the 2n. The n is going down to 2 to the n over n. So same to minus 1 to power n, x to the 2n over 2 to the n times reciprocal with denominator 1 over n. And simplify. What's that? Negative 1 to power n times x to the 2n over 2 to the power n times n. The next, simplify this one. What is minus 1 to n minus 1 minus 1 to n here? Minus 1 to n minus 1 times minus 1 to power n. So what's that? This is combine these things. Minus 1 to n minus 1 plus n. We have 2n minus 1. We can change it minus 1 to 2n times minus 1 to minus 1. Minus 1 squared is just 1. 1 to the n is 1. Minus 1 to the minus 1 is exactly 1 over minus 1 is negative 1. 1 times minus 1 is just minus 1. You can change it. This is what? Minus 1. Only take out minus 1. The final answer is ln of 2 minus summation from n equal to 1 to infinity. X to the power 2n over 2 to the power n times n. So that's it. This is the final answer. It's right. This is the whole idea by using the previous result, ln of 1 plus x equals summation from n equal to 1 to infinity minus 1 to power n minus 1 times x to the n over n. It's like a whole idea for solving this problem. The next tip. Find a power series representation for inverse tangent of x and its radius of convergence. We can use the similar method for solving the ln of 1 plus x. You can use the geometric series, the take derivative. Do you know what is inverse tangent of x? Could you write your answer on the chatting board? What is it like inverse tangent of x prime? Inverse tangent of x prime is, do you know what is inverse tangent of x prime? So could you write your answer? Yep. So we have this one, go like this. The next tip, you can change it. This one to the 1 minus x squared form. You can plug minus x squared into here, this one. So we have summation n equal 0 to infinity negative x squared to the power n. Distribute power n to the minus 1 and the x squared. Summation from n equal 0 to infinity minus 1 to power n, x to the power 2n, like this. Is right? So we have this one. Next, what is the radius of convergence here? What is like a ratio, common ratio? Common ratio is minus x squared. This is like rule, this one. Only plug this one into here, plug into here. So we have like this. The minus 1 is gone. Take a square root, is right? So take a square root. Absolute value of x is 1. The radius convergence is, yes, exactly 1. So we have it, this one. The next, we can use this one, take integral, right? Take integral both sides. This one, take what? Integral. Take integral. So like this. So what's like inverse tangent of x prime? So exactly the derivative and integral is gone. So just inverse tangent of x. So we have it. Next, only take out summation. Take out coefficient. Summation from n equal to 0 to infinity minus 1 to n integral x to the 2n. The same to what? Summation. N equal 0 to infinity minus 1 to power n. This one is power rule. X to the 2n plus 1 over 2n plus 1. You can add c. How can you decide c? The same things. You can plug x equal to 0 into here. Here, we can plug into here. Like this. The radius convergence doesn't change. You can take integral the radius convergence is exactly same to original one. The next substitute x equal to 0 into equation. You can plug 0 into x here. So what happens? This whole thing is going to 0. So we have the C equals inverse tangent of 0. Do you know what is inverse tangent of 0? Do you know that? So could you write your answer on the chatting board? What is inverse tangent of 0? Yeah, is right. So what do you think? The other students, do you have the same answer? Inverse tangent of 0 is like 0. You're right. So yes. So we have this answer. So how can you find the inverse tangent of 0 is unknown angle theta. So when you interchange theta and the 0, so we have 0 equals tangent theta. So which angle has tangent 0? So exactly angle theta is 0. So we have 0. So this is 0. So C equal to 0. You plug into here, so we have this one. Here, this one. So same. You have to memorize this one. So similar question. How can you find inverse tangent of x cubed over 5? How can you find power series of inverse tangent of x cubed over 5? So what do you think? How can you find the power series representation of inverse tangent of x cubed over 5? Take out 105, is it right? Take out, what's that? So this problem is a little bit different from like add-in function. So let me see. In this case, we don't have any constant, only x. So what does it mean? Here, only plug x cubed over 5 into x. That's it. This is the whole idea. Only plug into here. So what is the answer? Summation n equal 0 to infinity minus 1 to power n times x cubed over 5 to the power 2n plus 1 over 2n plus 1. So like this. So let me see. What's that? You have to keep summation n equal 0 to infinity minus 1 to n. I can do that. Distribute 2n plus 1 into x cubed. So we have x cubed to the power 2n plus 1 over bottom on 5 to the 2n plus 1 times the reciprocal of denominator 1 over 2n plus 1. Like this. Distribute 3 to the 2n and the 3, the same to x to the power 6n plus 3 over 5 to the power 2n plus 1 times 2n plus 1. We have it. So what's that? We have x to the 6n plus 3 over 5 to the power 2n plus 1 times 2n plus 1. So that's it. This is whole idea for solving this kind of problems. Does it make sense? The next, we think about the last problem. The evaluate integral from, not from, integral x squared over 1 plus x to the 7 dx as a power series. How can you do that? You can use same thing, geometric series. The first one, we think about this one, integrand. You can change it. Only take out x squared 1 over. Keep 1, you change in negative sign. We have negative x to the 7. So like this. The next here, only plug minus x to the 7 into the common ratio part here. Only plug into this one. So what's that? So this is the same to keep x square summation n equal 0 to infinity. Plug minus x to 7 into x, negative x to the 7 to the power n. The distribute power n to the minus 1 x to the 7 x square summation n equal 0 to infinity. So we have minus 1 to power n x to the power 7n. The next x squared is going to inside only add exponent 7n plus 2. So we have summation n equal 0 to infinity minus 1 to power n x to the 7n plus 2. So we have it. The next, how can you find radius convergence? Same. Only plug common ratio negative x to 7 into this x. So we have absolute value of negative x to the 7 is less than 1. Only eliminate minus 1. Absolute value of x to the 7 is less than 1. You can take 7 root. The both sides we have absolute value of x is same 1. So 1 is radius of convergence. So we have the radius convergence is 1. Doesn't change. The next, you can take what? Integral. So from here, the x squared over 1 plus x to the 7 is summation n equal 0 to infinity minus 1 to power n x to the 7n plus 2. So what's that? You can take integral the both sides. Here, you can take integral the both sides. So like this. So you can calculate. So what's that? Only take out summation n minus 1 to the power n. The summation from n equal 0 to infinity minus 1 to power n. Only integral x to the 7n plus 2 dx. So this is same to summation n equal 0 to infinity minus 1 to power n. The integral of this one is use power rule x to the 7n plus 3 over 7n plus 3. This is indefinite integral. Here, you don't need to find c because the original problem is indefinite integral. That's it. Only find radius of convergence. What is the radius convergence of this one? Could you run your answer on the chatting board? What is radius of convergence? Is it 1? Yes. The original one is 1. You can take integral, radius convergence doesn't change. That's it. This is a whole idea for solving this kind of problems. Right? This is the whole things. So procedure is like this, the same. So we have it. Okay, so this is the all for today lecture. So if you have any question, could you write your question on the chatting board? If you don't have any more question, you can leave live session. Thank you for attending my live session. I appreciate that you attended my class. So you're welcome. So you have any trouble, any question, always write your question on the discussion board or send the email to Kasha so we can help you. Okay, so thank you, all of guys. You're welcome. You're welcome.